We have seen several ways to use pointers. Now let's see one more. Let's see how to use pointers to save memory. In the next example, we shall create a structure to hold complex numbers, and with this complex number we shall start a function, a little function, which will get a complex number in the parameter list. The function will be very simple. It will only be able to print out the complex number in the a plus bi form. So start with the traditional C++ console application. Create a new non-Qt project with C++ application, and when you have the main function here, the main module here, we shall start with creating a structure to represent a complex figure. It will have two members. Both will be integers for simplicity. One img and the other one is real. And that's it all. And what our function will do, it will print it out. So the name is print, and the parameters are a complex number. And all this function will do is print out first the real member, then a separator character. In this case it will be the plus, and the C+img, and we shall close it to make the representation complete. We shall close it with the I character, and just to see it well, add an end line. So that's the function, and to be able to use it we have to declare it before the main function. But when we declare it, please remember the parameter list contains a complex structure, so by the time of the declaration the complex structure will have to be declared. So this is the place where we can declare print. And this is it all. Now create a number, a complex number, in main CPP. Give it a starting value, let's say 3 and 5. So we have a complex number to start with now, and print it. This time we don't need the cout as the standard output because it's involved in print. So all we need to do is print Z. Okay, the program is complete. Hopefully we can run it. The printout is 5 plus 3i.
And that's it. It works. However, at this point, let's have another look at the source code. We have said when a function is invoked, the argument is not passed to it as a reference by default, but it's copied instead. In other words, in this case, the compiler creates a local complex structure here, and when we invoke the function here, it actually copies the content of the complex number z into complex number c. In this case, it's not a huge waste of memory because we only have two members in the structure, but there are cases when, for example, you have huge, very big size, very complex structures or classes, and such copying is just not affordable because it's too much waste of energy to store the same variable in two places, in two locations of the memory. So what we can do here is, rather than passing the content of the variable, we can pass only the reference to the variable. And as we had seen it before, it's very simple. All we have to do is we have to indicate that the parameter list will have to handle the reference instead of the value of the parameter, which is, that's all. And this is what the printout is. It still works, so we did it well. However, in this case, the only thing we don't have here within the function is the explicit value of the pointer. All we do is we just indicate the compiler that wherever within this function C is referenced, it's actually not C, but the address of C, the memory address of C. But there can be cases when either we have the pointer generated, the pointer what we could use, or we may have a situation within the function where we need the explicit value of the pointer. So we can do the same as we have seen it already, but this time with pointers. Now the pointer will require a different invocation, because when we call the function, we have to call it with the address of the variable instead of the value of the variable. So now we pass the address of z to complex, and complex will get the address of this. So C will be within this function a pointer instead of a complex number. It has the other outcome here. We have to clearly instruct the reference operator to do it with an indirect reference. So rather than do it not on C structure, but a pointer pointing to C. And we have to do it both cases. Now the privileges of the operators are not trivial, so this is the way to use these two operators together. If we test the program now, it's still in a well-working order, so we did it well. And actually the example is completed, but at this point it's time to speak about this very complicated operator sequence here, the asterisk and dot. It is so often used, and we shall see it later. It's very, very widely used in Qt, for example. There is a special operator specifically for this situation. So the asterisk dot can be replaced with an arrow of the minus character, and the bracket symbol. Same here. And this is something you will see very, very often in a C++ code. Let's run it. And there we are. It still works.